I've just completed my trolling motor conversion project, so with no rest, it's on to the next thing. Once again, we're going back up into the treehouse. But my 3D printer is taking this project off. This time, we're diving into SolidWorks not just to solve a design challenge, but also a mechanical challenge, consisting of a gear study. Last summer we had our garage door and opener replaced, which left me with a working opener that had seen better days, but still had plenty of life left, and I could think of no better place to use it than in my treehouse project. I think it needs a trapdoor opener. The challenge is safety. I built the entrance so it could be closed to cover the hole leading 10 feet straight down. But the door is very heavy due to pressure-treated wood, and it's not easy for the younger children to handle. In other words, my safety feature isn't very safe to use. I kept all of the mechanical parts from the opener, the pulleys and cables, those giant springs that assist the lift, but the installers didn't keep the safety sensors. More on that later. It's time to get a plan together. Starting with the big picture, a standard garage door is between 7 and 8 feet tall in the US. The garage door opens in about 14 seconds, which we can verify with some quick tests. In contrast, my trapdoor is 32 inches in length, which an open angle somewhere short of 90 degrees, so let's just call it about 3.5 feet of travel. If you look at the size of my gear in relation to my cable pulley, 1-to-1 is clearly going to open my 2.5 foot door far too quickly. I can adjust the end travel as needed during the fine-tuning stage right on the motor, but there's no way to adjust the RPMs. So it's a fairly common item I can use that'll give me multiple gear ratio options. That's right, an old bike wheel. Shout out to my friend Brent for donating this to the project. Now it's definitely time to make SolidWorks work for me. I need to see how it's going to fit together based on a few key measurements like lengths of the chain and the cable. It's also going to make quick work helping me decide which gear gives me the reduction I'm looking for. This time I'm putting images on the faces as decals so they auto-crop to the face size. Some simple mock-ups of the known parts enhances the visual of the project. With family parts like gears, using a design table to easily configure the other 6 gears is a real time saver. Here, I like to make the second configuration manually with the features and dimensions I want to drive, and then I let the table auto-create, filling in all those values. Let's get these parts into the assembly. With a few mates, we're ready to go. I'm using a combination of gear mates along with the belt and chain feature. They accomplish the same movements. I just enjoy getting it as close to reality as possible. I had to stop myself from adding the full working chain. SolidWorks automatically assigns the values and the movement is immediately evident. Not slow enough. Let's try the largest one. Yep, that's it. Last, I need to 3D sketch the best path for the cable so we know where to drill and to attach the pulleys. Now it's time to fabricate something to join the chosen gear with the pulley, and the leftover parts from the garage door hardware will do the job perfectly. I needed just a minute to harvest a section of the shaft with an angle grinder. Brackets and bearings will get new life. And the custom gear stack is complete. Get in there. Okay, great. Come around to this side. Good. And go. There you go. Let the drill do the work. Now pull up. A few more minutes with the help of my trusty assistant Kennedy, and we have a finished assembly. And when you're ready, squeeze. When you feel it go through, now pull back up while it's still spinning. Up in the tree, we duplicate what we've already proven out in SolidWorks. Kennedy and I get the holes drilled and the pulleys in place. And with a little adjustment to the position of the motor and the opening end point, everything is working as anticipated. And there's nothing more satisfying to an engineer and dad. The Treehouse is now fully equipped with 2 buttons and a wireless remote. And without the safety sensors, they have to hold the button down to close it, so no accidental pinches. Looks like that closes the door on another project. No matter what your task, the incredible versatility of SolidWorks can give you the confidence you need to move forward. Contact DASI Solutions and we can show you how.